So welcome back. In previous lectures, we discussed two design units of VHDL language. Those are entity declaration and architecture body. What is the purpose of entity declaration or what for it? Yes, to declare inputs and outputs of a digital system can be done through this entity declaration. Then what for architecture body? To describe the internal action of a digital system, right? Now, in this session, I would like to discuss the other design units like package declaration and package body. So, package declaration or packages, the purpose of package is in order to share your design units to the others. The sharing can be possible if you place your declarations in the packages. What is the purpose of sharing? So once you share your declaration to the others, the other one no need to declare once again. That is the use of the sharing. Okay. So the packages are represented as two. One is package declaration and package body. Let us see the syntax of package declaration. It starts with the word package, then package name is. This is the first line. The package name is user defined name, that is it is identifier. Then different declarations which you can declare in the package are subprogram declarations. Subprogram declarations means yes, function declarations, procedure declarations. Subprograms are functions and procedures. Okay, their declarations you can done in package declaration. Then type declarations. What is meant by type declaration? The user can define his own data type. That is the type declaration. Subtype declaration. Okay. So in order to represent a specified range from the base type, the subtype is declared. Constant declarations, signal declarations, file declarations. These three are the clauses in case of our data objects. Okay. So object declarations like constants, signals, files, and component declarations, use clauses. Component declarations means already we have seen in the structural model, one declaration is compulsory in the declarative part of architecture body, that is component declaration. The syntax of it that you can see in the later classes. Then use clause also you can see in the next classes. Finally, the package declaration is ended by the word end followed by package name. Okay. So this is the way these are the different declarations you can place in the package. Let us see one example. Package ECE is different declarations in this are like this. Coming to first statement in the declarations, constant rise time colon equal 10 nanoseconds. What does it mean? Rise time is an object of class constant. It holds which type of data? Time type of data. And what is its value? 10 nanoseconds. 10 nanoseconds. So another one also a constant object. Its name is fall time. Also it holds time type of data, but no value is assigned here. No value is assigned. That's why it is called deferred constant. But where the value can be assigned, that is in the package body. That is done in the package body. Then variable declaration, signal declaration represented. So D0, D1, D2 are the objects of class variables. They hold which type of data? That is standard logic data. Similarly, E0, E1, E2 are the objects of class signals. They can accept standard logic type data. Okay, what is standard logic? Standard logic is a predefined data type, 9 different values it consists. Okay, in the predefined data type list you can see what are the different values in the standard logic. Then one type declaration is there. It comes under enumeration data type because the values are the literals. Okay, so its name is digit. Its name is digit. Consists different values like 0, 1, 2, 3, 4, 5, 6. And another one is subtype middle. Its name is middle. Its base type is digit, but the middle has the values from 2 to 5 only. 2 to 5. That is 2, 3, 4, 5. Okay. Then one component declaration. Component declaration. Its syntax is similar to entity declaration. This is the component declaration for XOR gate. XOR gate component declaration. It has 2 inputs and 1 output. Then another one is subprogram declaration like function. Okay, function add bits of x comma y. X comma y are the parameters. You know, in case of function, the parameters mode is only in, and their data type is bit. Return data also bit type data. Yes, this is the declaration of the function. Okay, like that, different declarations you can place in the package declaration. Okay, so usually followed by package declaration, sometimes you have the package body. It may not necessary. That depends on the declarations which you placed in the package declaration. Let us see the package body syntax. Start with the name package body, then package name, then package name. Okay, that means the package body name must be equal to package name. Okay, compulsory, you must remember it. The package body name must be equal to the package name. Is then package body item declarations like subprogram bodies. Here the body of the subprogram can be presented. Then complete constant declarations, that is for the deferred constant the value can be assigned here. Okay, some subprogram declarations also can be done here. Type and subtype declarations, file and alias declarations, use clauses. So about alias declarations and use clauses you can see in the later classes. And similarly the package body is ended by the word end followed by package name. Okay, so that is the necessity of packages and their syntaxes and examples. Okay, I think package body also has an example here with the name package name. That is ECE. It has 2 declarations, one complete constant declaration with assigning the value. Another one is function body. Another one is the function body. Okay, so that is about the packages. Then coming to implicity or visibility. Coming to visibility, there are 2 types of visibilities in the language. One is implicit visibility and another one is explicit visibility. Implicit visibility means like scope. Whatever the signals you declare in the entity, their scope is up to their architecture body only. Okay, because in the architecture body itself we are writing entity name. So therefore whatever the declarations done in the entity name, those declarations this architecture can inherits. Why? Because the entity name represented in the architecture syntax itself, right? So this type of visibility is called implicit visibility. Then explicit visibility means one design unit declarations can visible to another design units. units. Okay, that is called explicit visibility. That means, for example, now if you want to share your declarations, first of all you have to place those all declarations in the package declarations and package bodies. Then how can you make these declarations visible to the other design units? Okay, that is done by through explicit visibility. Through explicit visibility, but it is achieved through context clauses. Okay, there are two types of context clauses. One is library clause and another one is use clause. So using these two, you can make the explicit visibility, right? So therefore, generally these two clauses appear before the beginning of the entity design unit. Before the beginning of the entity design unit. Okay, for example, uh, if you take this one, if you take this diagram, so whatever the declarations are there in the library ECL, those are all visible to this entity Rx only. Similarly, whatever the declarations you have in the libraries ATT, CMOS, okay, those are all visible to the package arithmetic. Okay, similarly, whatever declarations you have in the library 1, those declarations are visible to the entity BCD3. Okay, so therefore the explicit visibility can be done by using library clauses and use clauses. So let us see the syntax of library clause. Library, list of logical library names. List of logical library names. More than one library name you can use along with the word library. Okay. So whatever the declarations you made, those has to place first of all in the package, and the packages must be placed in the library. Okay. Then with the help of the library clause, you can make visible that libraries like this. So here is one example, library TTL and CMOS. So therefore the TTL and CMOS libraries are visible. Okay, now with the help of use clause, you can extract or you can open the packages which are available in these libraries, that is library TTL and CMOS. So coming to use clause, there are mainly two forms. One is use library name dot primary unit name. Okay, another form is use library name dot primary unit name dot item. That means, what does it mean? See in this example, library CMOS. That means it opens CMOS library or it make visible CMOS library. From that CMOS library, you are taking the unit is NAR2 with the help of the use. Okay, so the other examples also see like this. So the standard library in the language is IEEE. Okay, IEEE. It is made visible by the word library IEEE. From that library, here we are opening one package named as standard logic 1164. Okay, how can you open? Using use IEEE dot standard logic underscore 1164. Okay, now whatever the declarations are available are declared in this package, those are all visible. Okay, like this. Okay, so that is the library and use clauses. Their purpose is to make the explicit visibility, right? Okay, in the next classes you can see the design elements of VHDL language. Okay, so if you have any doubts, you can contact through phone or email ID.